There are things that we find difficult to deal with when it comes to uncertainties, probabilities, complex causal relations that psychology has been looking at for decades. There are many aspects of the climate debate that make it a really kind of diabolical problem from the perspective of how we process information. And so the point of the paper is really to say, look, there's this literature out there, there's these different areas of psychology, and here is some food for thought, really, about issues you might want to think about when you're presenting your science. One of the key issues here is when people are asked to make their own judgment about whether or not the climate is changing. Often they substitute the word climate for weather. And so they think about the weather last week or the weather earlier in the year, and they maybe use that as a judgment, as the basis for their judgment, rather than the long-term scale that we should be looking at. If there is that misconception and that confusion, and that disconnect needs to be rectified. So recency is just a way of saying that things that have happened more recently are more likely to be retrieved from memory. For example, the very cold winter that they recently had in the Northern Hemisphere can create a bias in people's perceptions about whether or not the planet is warming. The media want to make for good TV or good radio by having people argue with each other, and therefore they want to sort of try and portray what they see as a balanced perspective. One person who's a quote-unquote believer and one person who's a quote-unquote denier, and we want to see them go at it. The problem from the perception of people trying to make their own judgments about what's happening is that there's then a bias in the sample of information that they're receiving. So if they see these debates where it seems, for all intents and purposes, that there's a 50-50 likelihood going on, then one possible outcome of that is that the person viewing it will think, well, if the experts can't make their own decision, then my guess is as good as theirs. It's the training. We're trained to put statements in terms of probabilities, likelihoods, and uncertainties. The problem is that that type of language is then immediately jumped upon by people that want to challenge it and say, well, look, you don't even know. When you're talking about numerical estimates, there's a phenomenon known as anchoring, or anchoring and insufficient adjustment, whereby people can, if they're uncertain about a particular value, so for example the concentration of carbon dioxide in the atmosphere, and you give them some value to anchor on, then that can sway their estimations about the actual quantity, and that can also then have an influence on the severity of the problems. For example, if I said to you, do you think that the concentration of carbon dioxide in the atmosphere is greater than 100 ppmv? And then I asked you to make an estimate, versus if I said to you, do you think it's greater than 1,000 ppmv? And I asked you to make an estimate. If you didn't really know, then the chances are that when I gave you that 100 anchor, your estimate would be lower than if I gave you that 1,000 anchor. There's lots of research showing that people find it easier to reason with numbers if they're put into what's called a frequency format. So if I describe something as 10 out of 100 rather than 10%, that 10 out of 100 seems to lead to more kind of concrete images of what I'm talking about. And it's often the case, I think, that the climate scientists are obviously going to be typically much more adept with the facts, the figures that they're using and the concepts that they're using than the audience that they're talking to. And so having some knowledge about that, the fact that mathematical equivalence is not the same as psychological equivalence, is important. Well, there are different ways that you can describe the concentration of CO2 in the atmosphere. One way is to talk about it in terms of its just concentration. Another way is to think about how thick it would be if you collapsed it into a single layer. And if you think about it in terms of its concentration, it comes out as a very infinitesimal, small-sounding number. But if you think of how thick that makes it in a layer, then it suggests that it's 8 meters deep. And an 8 meter deep layer of CO2 somehow has a bit more impact than just thinking about this very small percentage. So the classic ways of thinking about how people make judgments and how people make decisions is to take a rational model. But of course, we're not just pure number crunchers when it comes to these sorts of decisions, and emotions play a very strong role. And in a complex issue like climate change, emotional appeals, if you like, can have some important influences. And this again gets back to the analogy, or using kind of emotive imagery to try and display what the possible outcomes of climate change are, and to try and make those again more concrete, to try and get people to use the images which then can feed into the affect, the emotion that they then put into their decision. Important caveat here, though, I think, is that there's research showing that people have what's called a kind of finite pool of worry, so that you don't want to overload them with these catastrophic outcomes, because then there's a real danger that people will just throw their hands up and say, well, it's too late. Another issue that comes up in a lot of the research that's out there looking at the connections between psychology and climate change is this notion of temporal construal or temporal discounting, so how we think about decisions and impacts of things in the near future versus the distant future. So if you think about the possibility of sea level rises in 50 years, then you have the kind of abstract idea of what that might be. But if you think about the possibility that the river near your house is going to break its banks on Saturday, then you might have a very concrete image of what that will do to your living room carpet, for example. And so this overcoming this tendency to discount the future is a key problem in communicating the science of climate change, because a lot of the impacts that are being talked about and a lot of the sort of targets that are being discussed are in terms of things in 50, 100 years' time. So tying things into more concrete outcomes, or giving some kind of image that people can hang on to make those outcomes less abstract and more concrete, is an important part of the job, I think. One of the key insights from work looking at people's decisions under uncertainty and choices made under risk, or in this case, the uncertainty of what's happening to the climate, is that people are much more affected by loss than they are by the equivalent gains. The pain associated with losing $500 is much more than the pleasure associated with receiving the same amount. One way to try and get across the importance of turning lights off and recycling is, rather than thinking about the incremental gains, is to emphasise that if you don't do these things, there are going to be some serious losses. I think the one that is perhaps beginning to get through to people is that their electricity bills are going to go up, and they're going to go up by a lot, and that's going to be a big loss, and that loss is going to be felt psychologically a lot more than the gain that you're getting in saving. There's a whole literature on whether you frame problems in terms of losses or whether you frame problems in terms of equivalent gains, and it shows that there's this loss aversion. People don't like losing money. If you take an analogy of smoking and lung cancer, so for most of us, our mental model, if you like, of or causal model, if you like, of the relations between putting a cigarette in your mouth and inhaling the smoke, and what that may have, the effect that may have on your lungs, and therefore your likelihood of getting lung cancer. In terms of how well they're bolted together, we may not need to know the specific links at every point, but if you ask people to, if you like, sketch out on a bit of paper, well, how does putting a cigarette in your mouth, inhaling smoke, lead to cancer? Then they could at least draw the appropriate arrows between the links, if you like. If you do the same thing for climate change, I'm not as confident that people will be able to understand how lots of different things contribute to the amount of carbon dioxide in the atmosphere. I think it is important to try and not bolt the whole thing together in the way that eminent climate scientists would be able to draw such a diagram, but at least get some basic understanding of how our emissions are going up, what we need to do to reduce them, and how we can try to increase our chances that the globe is not going to warm to dangerous levels. one of the things we discuss in the paper is this term groupthink, which has become a kind of catch-all label really for defective decision-making that comes out of this dysfunctional groups. Now, the climate community is in no way guilty of groupthink, but the problem is that because of the way the debate is often portrayed in the media, I mean, the climate gate total non-scandal is a good example of the idea that they're not listening to anyone else, that they know the answers already and that they're not listening, and that's symptomatic of this groupthink idea. And so, although I'm not saying that the climate scientists are actually in that situation, the perception that they might be because of the way things are portrayed is a possibility, and the possibility is increased if people engage in the divisive kind of us and them, believers, deniers. There's some interesting work on the way that sort of skepticism and the denier culture has developed in other situations, and how eventually the fact that the arguments that the skeptics are holding become increasingly untenable as the evidence mounts against them, and eventually they drop away, and then things have to start moving. And I think that, you know, the idea that the weight of their own inconsistencies in their arguments will be the ruin of them in the end. Whether it's going to happen quick enough is another question.